also going to decorate my class with the disallow concurrent execution attribute, which is going to make sure that there's only one Outbox Messages job instance running at any given time. This is going to solve any concurrency problems. Now I'm going to add the dependencies that will be required for this background job, and let me walk you through what I'm going to add. I'm going to use the SQL connection factory because I'm going to use Dapper to query the Outbox Messages table and update the processed messages. I'm going to use the iPublisher from Mediator to publish the individual domain events, the datetime provider to record when a given Outbox message was processed, the Outbox options instance to get the batch size, and the iLogger to log some contextual information. I'm also using a JSON serializer settings that's going to match the one that I added in my application database context. And now let's focus on implementing the execute method. The first thing I'm going to do is to add an information log saying that we are starting to process our Outbox messages. Then I'm going to use my SQL connection factory to create a new database connection, and I'll use this connection instance to open a database transaction because I want to process all of my Outbox messages inside of a single transaction and make sure that they are all processed together. Now that I have my database connection and the transaction, I'm going to be querying the Outbox messages table and returning back a collection of Outbox messages. I'm going to use a simple record to represent my Outbox message response. It's just going to contain the message ID and the content, which is a JSON string, which I'm going to use to deserialize back into a domain event instance. And then I'm going to add the implementation of the get Outbox messages async method. What's interesting about this method is that I'm using a select for update query, which is going to lock any rows that are queried as part of a database transaction until we commit that transaction. This means that if there are competing transactions or multiple instances of your background job running, these rows will be locked and the concurrent instances of the process Outbox messages jobs won't be able to read those rows, which is really useful because you only want to process your Outbox messages once, which is why I have a filter here where the processed on UTC column is null and we are just projecting back the ID and the content, which matches the properties on the Outbox message response. I'm highlighting the for update clause again, and this can be practical when you need to scale out your background job to be able to process more Outbox messages, which could be a requirement in high throughput systems. Now that we have the Outbox messages in our execute method, let's add the processing logic. And this is going to be a for each loop where we are going to iterate over each Outbox message instance. We're going to try to deserialize it into an iDomain event instance by passing in the Outbox message content and the JSON serializer settings. And I'm going to try to publish this domain event using Mediator. If we encounter any exception, we're going to log the exception together with the message ID so that we know which message triggered the exception. And I'm also going to capture this exception in the exception variable and send it to the Outbox message async method. This method is going to update my Outbox message after I'm done processing it. So let me add the implementation here. It's just going to set the processed on column to the current time, and the error column is going to be either a null string or it's going to contain the exception that we caught while publishing the domain event. So after we are done processing all of the Outbox messages and our for each loop completes, we're going to commit the database transaction and add another information log that we have finished processing our Outbox messages. And this wraps up what's required in the process Outbox messages job, but we also need to configure it with dependency injection. So I'm going to go back to my add background jobs method, and first I'm going to configure the Quartz services by calling add Quartz. And I'm also going to add the Quartz hosted service, and I'll configure the options instance to wait for jobs to complete when the application is shutting down. One more thing I need is to tell Quartz to run my process Outbox messages job. And I'm going to do this using the iConfigure options approach by creating the process Outbox messages job setup class. This class is going to implement the iConfigure options interface of the Quartz options type, and I'm going to add the configure method. Let's also inject the Outbox options instance so that we can access the interval in seconds, which we're going to need to configure how often we run the process Outbox messages job. Inside of the configure method, I'm going to call some methods that are exposed by Quartz. I'll use the job name as the key for configuring my background job, and I'll call the add job method on my Quartz options. Then I'm going to configure the job identity using the job name constant, and I want to add a trigger for this job to run with a simple schedule, and this schedule is going to have an interval in seconds, which will be determined by my Outbox options instance and the interval in seconds property. And I want to repeat this job forever as long as my application is running. I also need to configure this class with dependency injection. So let's add that here. We're going to say configure options and then specify our job setup. And now let's run the application and see how the process Outbox messages job actually works and how publishing the domain events out of process is going to improve the reliability of our system. We're going to send a post request to our API to attempt to reserve a booking for the current user. I placed a few breakpoints and some interesting points in our code so that we can observe more closely what's going to happen. So let's send this post request. And first we hit a breakpoint in our command handler. So I'm going to hit continue, and if everything goes well, we're going to land on this breakpoint here, calling the unit of work save changes async method. So this is what happens, and I'm going to press continue again, and we land inside of the save changes call in the application database context. So here I'm going to step through and go into the add domain events as Outbox messages. We're going to see if we get an Outbox message instance. And you can see that our collection does contain one Outbox message, which is the booking reserve domain event. So we're going to add this to the change tracker. And then when we call save changes async, everything will be persisted together as a single database transaction. If we take a look at the logs in Docker, you can see the update statement here to the apartments table. Then we have an insert into the bookings, and most importantly, we have an insert into the Outbox messages table. So I'm going to hit continue, and we hit another breakpoint inside of our process Outbox messages background job. So the Outbox message that we are processing is, as you might expect, the booking reserve domain event. So let's see what's going to happen. I'm going to try to deserialize this, and we get a domain event instance. Then I'm going to try to publish this domain event, and we hit the breakpoint in the domain event handler. And here we're going to just step through, fetch the booking, fetch the user, and call the email service to notify the user that they have 10 minutes to confirm this booking. Finally, we're going to update the Outbox message that it was processed so that we don't pick it up again when we run our background job. And finally, we're going to commit the transaction, release any database locks, and the background job will start another iteration. Let's give this flow another try with a different apartment, and I made some interesting changes in the background. So I'm going to send this post request to our API, and we get back a 201 created response, raise the domain event, which gets saved as an Outbox message. Behind the scenes, my background job is going to run and hit this breakpoint, and I'm going to deserialize the Outbox message into a domain event and attempt to publish it. So let's see what's going to happen this time, because I made some updates in the email service. Instead of completing successfully, the email service is going to throw an exception. So I'm going to press continue, and you will see that we land inside of the catch statement in our background job. So we're going to catch this exception. We're going to log it for this particular message ID, and we're going to store the exception in the exception variable. Then I'm going to update my Outbox message with an error, which is going to contain my exception details, and the next time the background job runs, this message will not be processed, but this gives me the flexibility to easily implement retries for my Outbox messages. For example, I can record the retry attempts in a separate column in the Outbox messages table and attempt to publish the respective domain event a given number of times. So in this case, I'm just going to store the error in my Outbox message row and commit the transaction, completing this run of the process Outbox messages job. And this is how you can integrate background jobs into the clean architecture using Quartz, and in this example we used it to implement the Outbox pattern.